Okay, now in this video we'll discuss our question 2 for this prelim September 2022 question paper. In the description below uzothola ama-link for amanye ama-questions akhona kule question paper. Right, lana sino question 2 ukhuluma ngo-Newton's law. Lana sina 2 yama-objects u-P no object Q. Both objects are sitting on top of a inclined plane, and then there's a force applied between the 2 objects. There's a string. The inclined angle is 30 degrees, right? And then the blocks remain at rest when a force F is applied parallel to the plane on block Q. The static frictional force on block P is 16.97. So babuya basipha nani nama-masses walama objects way 2. And then nama-mass basiphe wona. P is 5 gram, Q is 3 kilogram. Now siyabona ke ukuthi u-P uzomove from A to B, maybe eventually to C, but the takeaway la ukuthi u-P is the only object they experience in a rough surface between A and B, but Q is on a frictionless surface. Njengoba basho lapha phezulu bathi u-P is on a rough section and then Q is on a frictionless section. Now with 2.1 but state Newton's first law. A body at rest will remain at rest, and a body in motion is a continue in motion with a constant velocity unless acted upon by a force. So now lana siyabona initially the blocks were remaining at rest and then apply a force F. So hence must define u Newton's first law. 2.2 free body diagram ga block Q. So this is the free body diagram ga block Q. So for the first 2 questions, I expect you to collect my marks la. Stating a law, free body diagrams, these are free marks, man. Free marks. So block Q na free body diagram yakhona for 4 marks. Now bese ku 2.2 siyabona ukuthi there's 4 forces. So the normal force, the force applied, tension, and the gravitational force. So it's 4 marks for each vector. Now 2.3, calculate the magnitude of F. 2.3 but is calculated F. So F some calculator kanjani ke. Now F singam calculator by looking at the information abasiphe yona la. So basiphe ini static frictional force. Basiphi static frictional force at block P, which is 16.97 Newton. Now yini static frictional force, or let me say what's the difference between a kinetic frictional force and a static frictional force. Kinetic frictional force ile force le experience a object in motion. The frictional force experienced by object in motion, and then gube static frictional force, which is the frictional force ekwamele si overcome in order for the object to move, right? Imagine a box ehleli phezu kwetafula, ngisebenzisa i-index finger yami to move the object, I move. Ngisebenzisa the second finger ngithi ngimove le box, I'll move. Ngisebenzisa the third finger ngithi ngiyayimove le box, I'll move. It means that the force or lama force engizama ukwa apply to the box akavumi uku overcome or are less than the static frictional force for that box, right? And then sengidecide ukusebenzisa izandla zami zoyi2 ke manje. Once ngisebenzisa izandla zami zoyi2, then boom, the box starts moving. It means that the force apply it's greater than the static frictional force. That's why I say move la. That's why lelo box elenzani sel move ke manje. And then I'll move so it's still experiencing a friction, but this time sesibiza ukuthi is the kinetic frictional force because of the object is in motion ke manje, right? Now 2.3 calculate our F. So in order to calculate to F, sizosebenzisa le block ka Q ne block kabani ka P. So sosebenzisa ama Newton's laws. So since the objects are stationary, then apply ilo kanje force F, which is the force okumele si calculate. So qala ngo block Q, F net is equal to 0. So Newton's first law, F net is equal to 0. So F net, let's choose the the direction upward as positive. So ubheka la object yakhe imove khona, like block Q move parallel to the inclined plane, block Q parallel to the inclined plane. It means that F net, the net force, so a calculator using the forces which are parallel to the incline. So the forces which are parallel to the incline, it's 1, 2. There's also a third force, the parallel component yaga F bani, yaga FG. So this one. I shall learn us know FG perpendicular, and then sibe no FG parallel. So this FG parallel is also parallel to the incline. So FG tension as well as F. Uma ngiba add banginikeza ubani F net. So I'm choosing up as positive. So therefore it means it's plus F minus T minus FG parallel equal to 0, right? Why FG no T ba negative? Because bona ba facer down, and down is over negative. Therefore F unknown minus tension is also unknown. Yeah, but so let's calculate tension before we can calculate to F. So FG, it's mg sine 30 degrees, and then the perpendicular one is cos 30 degrees, and then F minus T minus mass. What's the mass for Q? For Q it's 3, 9,8 sine 30 degrees equal to 0. F minus T minus I think keep it calculator, get it 3 times 9.8 times sine, so lana it's 3 times 9.8 times sine 30 degrees, okay, I think erase la equal to 14.7. So 14.7 equal to 0. So therefore F is equal to T plus 14.7, T plus 14.7 low T. So ngizodinga ukucalculate u-T in order ukuthi ngithole ubani u-F. So u-T so calculator using ubani u-P ke manje. Let me erase lana so that I can create some space. Okay, now sesilana ku block Q. So this is the block P. So this is the free body diagram ka block P. Tension T, and then FG parallel, which is the component ka FG, and then sibe no F static, which is given as 16.97. Now COT ke manje, COT choosing up as positive again, F net was over equal to 0. F net it's plus T minus F static minus minus FG parallel equal to 0. Okay, now SSCT tension minus static 16.97 minus 9.8 times 5 sine 30 degrees equal to 0. Then simplify again manje la. So tini 16 minus 97 minus lana, it's negative as well, so it's negative, and then 9.8 times 5 times sine 30 degrees equal to minus 41.47. so t is equal to, the answer is negative, nangiletha ngaphi ba positive, about 41.47 newtons, right? 41.47 newtons. So therefore sisakhumbula ukuthi F is equal to tension plus 14.70, right? So substitute out T lapha bese usinikeza ubani u-F. Okay, then answer yethu kuzoba force equal to 41.47 plus 14.70 is equal to 56.17. Now sisiya ku 2.4 bathini ke la, what the applied force F is now increased to 85 newton. So umunye umuntu angazibuza ukuthi for 2.3 ama calculations angaka lana. I was explaining in detail, right? So there's always a way of writing down or doing ama calculations, tata ama shortcut, so that you accommodate lama marks lao. So lana was just explaining, right? The applied force F is now increased to 85 newton. The kinetic frictional force on block Q is 44.5 newton. So yabona ukuthi now there's kinetic frictional force. Why? Because of the 85 is bigger than the required force to overcome any static friction. So anything bigger than 56.18, le system yethu izowenzani, izomove, yeah, izomove le system yethu, right? So now it's 85, it means iyenzani, move, and it's not only moving but it's also accelerating. Now the kinetic frictional force now 4.5 newtons. So now I experience statics in a kinetic frictional force. 2.4, apply Newton's second law on each of the blocks to calculate the magnitude of the acceleration of the blocks while the blocks are still accelerating. No question etiphelelala, full stop. So let's calculate the acceleration yalama blocks, full stop, right? At in erase la. All right, now so you pendula 2.4 supplier on each of the block Q and P. So sizowenza so ke manje. This is the free body diagram kabani ka block Q. Now tension, now this is the parallel component for FG, and then sine applied force kubani go block Q. So therefore this time F net is equal to mass times A. This is Newton's second law, right? So F net, if I'm choosing up as positive, you're about 85 minus FG parallel minus tension equal to mass ubani for Q it's 3, and then A 85 minus mass times G 3 times 9.8 sine 30 degrees minus tension is equal to 3A, and then nang simplify lapha 85 minus 3 times 9.8 times the sine 30 degrees, this is equal to okay, yeah, it's plus lapha, so it's 70.3. 70.3 minus t equal to 3a. So this is equation 1. Also siyazi ukuthi second law kuba ne-simultaneous equation. Now let's focus ku block P ke manje. This is block P. Block P again sebenzisa ubani? Second law. So the second law, F net is equal to MA. F net up is positive, so we about T minus F K minus F G parallel equal to 5A. Tension unknown minus FK 4.5 minus FG, so it's M, it's 5 mass gravitational acceleration 9.8 sine 30 degrees equal to T minus 29 equal to 5A. So therefore this minus 4.5 and then this 5 times 9.8 sine 30 degrees, and you put 29. So this is our second equation, right? This is our second equation. So therefore senior solver simultaneously so that ngizokwazi ukuthola ini i-acceleration yami. So into esoyenza ke manje le, right? Remember the previous equation bekubani? Beku equation 1. So therefore athi nginikeze a summary for ama equations wethu lana. So let me erase this. So equation 1 was this one, equation 2 it's this one, is that we told manje, right? So in order to find acceleration, instead of using a substitution method, you use the elimination method. It's easier that way. Now you add to equation 1 or equation 2. You add our equation 1 or equation 2. So you the equation 1 plus equation 2 is equal to, okay, I don't like using equal sign, so let me use the colon. So equation 1 I'm going to add an equation 2. This adds up to this one. So 70.3 plus minus 29 is equal to 41.3. 41.3 minus t plus a t eliminate each other equal to 3a plus 5a is 8a. Divide by 8 divided by 8. Divide by 8, the answer yami ubani? 5.163. 5.163. Answer acceleration, it's in meters per second squared. So this is our acceleration. So both objects as accelerator ngale value, they are both going to accelerate to 5.163. Right, so 2.4 uphelela la. Now the last question 2.5. 2.5 bathini ke manje? 2.5 bathi while the blocks are still accelerating up the slope, the steering suddenly brakes. Let us plot a velocity time graph for the motion of P and Q before the steering brakes as shown below, right? Lana komele si redraw the graph above, and then on the same set of axes see draw a graph for each of the block after the steering broke. Label each graph clearly as P and Q. So I think erase it la. Let me erase 2.4 bye. So I go 2.5 again manje. So I go 2.5. Okay, I think redraw a low velocity time graph. So this is the velocity time graph. Well, it's an exact copy of that one below, but ngifuna ukupointa out something ke la. So into ezowenzeka if u-P no-Q baya move up the slope while bayenzani baya accelerate ngisho baya accelerate because of there's a force applied la, right? There's a force applied and then accelerator. So if the string breaks again, right? If the string breaks, okay, now sifuna ukwazi ukuthi what will happen to P no Q after the string has broke. Now this is what's going to happen to P. So this is the graph for P. Because of P rough section, yena i-velocity yakhe izowenzani izo drop all of the sudden. Why dropper? It's because of the friction kulelo kanje. The friction in between A no B izo slower down ubani u-P. Now for Q will obviously continue moving up the slope. Why? Because of there's no friction and the force applied is where is being applied to Q block, right? So yeah, if video etiphelela lana, thanks for watching, thanks for tuning in. Nangabe enjoyed this video, please leave a like, ungakhohlwa ukukhomenta, ungakhohlwa ukubuza ama-question in the comment section. Nangabe new to this channel, please consider subscribing. Thanks for tuning in. Asibonane kule video elandelayo. Bye bye.